Hello guys, so let us go ahead and look at a proof question proving that the left hand side is equal to the right hand side. And so this question says prove that this trigonometric equation, the left hand side is equal to the right hand side. Essentially, you must just prove that, and state restrictions where applicable. Okay, we will see what they mean by that. But for now, let us go ahead and prove that the left hand side is equal to the right hand side. So when you have to prove, you have to choose. Do you want to work with the left hand side or the right hand side? The best way to choose this is to work with where you see, choose the one where you see you have more to work with. So in this situation, we can see that the right hand side kind of looks simplified. It's just one fraction. Whereas with the left hand side, there is more. We can expand, we can change, we can manipulate, whatever. So there is more to work with on the left hand side. And so we are going to choose left hand side. We want to start by saying LHS is rewrite that minus tan angle cos angle tan angle plus cos angle, right? Which is equal to sine squared angle. So yeah, when we look at these two fractions, we can see that these two terms are the same, but with different signs. And so in this situation, when the two brackets have the same terms respectively, but with different signs on each, you just want to multiply the first term of the first term and the last term of the last term, right? In a FOIL-ish method. Okay, it's a simplified FOIL method, but yes, that's the rule when you have two terms that look alike, but the signs are different. You want to multiply first by first and last by last. So first by first is tan angle, which is tan squared angle, minus cos angle multiplied by positive cos angle is minus cos squared angle. And so we go ahead and simplify this. Negative, multiply negative inside the bracket, we get negative tan squared angle positive cos squared angle. So if you put the sine and cos next to each other, you will see that cos squared angle minus tan squared angle. This is a trig identity. What do we know about sine squared angle plus cos squared angle? It's equal to 1, right? Trig identity, remember this. So we get 1 minus tan squared angle. And so we can change this tan to be 1 minus sine squared angle over cos squared angle. So this one we want to change it so that there's a common denominator, right? So once we change this one, it's going to be cos squared angle over cos squared angle, which is 1 because once you cancel, it's 1. We just want to make sure that both have cos squared angle at the denominator, minus sine squared angle over cos squared angle, which is going to be cos squared angle minus sine squared angle over cos squared angle once you combine everything, right? And so we can see that, okay, does indeed look like the right hand side. And so you always want to conclude by saying it's equal to the right hand side. Okay, so we have proved that indeed they are equal, right? And then it also said state restrictions. So let me just shrink this for enough space. So what do they mean by this? State restrictions were applicable. So restriction means that the angle for which this will hold, where this won't be undefined. So what do we know about an undefined equation? The denominator must be equal to 0. So this denominator must not be equal to 0. So what is the restriction there going to be? Firstly, you want to equate the denominator to 0, right? And once you square root this, okay, before I do that, remember you can write cos like that is equal to 0. You want to square root it, still going to be 0. And so the restriction is that when you go to your calculator and press shift cos 0, we're trying to solve for an angle now. The angle must be restricted. This is the restriction we're talking about. The angle must be restricted to a certain angle. So it's going to be 90 degrees. And we know that for the general solution for cos, it's going to be k 360 degrees. Or angle is equal to 360 minus 90 degrees plus k dot 360 degrees. What is 360 minus 90? 270 degrees plus k dot 360 degrees. So essentially what we're saying here is that the angles must not be these. So the angles must not be these answers, because if the angle is 90 and 270 plus, as you keep on, forgot to say k elementary, so the angle must not be 90 and 270 and other corresponding angles as you keep on adding 360 degrees. If they are those answers, then this fraction is going to be 0 and it's going to be undefined. So we don't want a case where it is undefined. So this restriction, it places a restriction that this angle over here, it must not be these answers. Otherwise, we're going to get an undefined answer fraction over here. That is the restriction that they are talking about, right? And yes, that is how you go ahead and prove and restrict this solution. Thank you very much.